Greetings! Today we have an Atari Pinball CPU board in unknown working condition. For those of you following my channel, you may remember that a few years ago I bought a half-dozen Atari pinball machines, had them shipped out to me, and there are several videos showing progress on those, how they were brought back to life. And what happened though is this comes out of a Airborne Avengers machine. In my original purchase there were two Airborne Avengers, but one was in poor shape, and cosmetically that is, and the other one was in a little better than the first one's shape, but still they weren't something. I was looking forward to getting something a little better looking. So it wasn't too difficult for me to sell both of my Airborne Avengers, and now I was lucky enough to find another one that looked like it was cosmetically in better shape than the other two. However, I bought this in pieces, no guarantees, no nothing, and this is a CPU board that came out of it, so the machine's still sitting in the garage. I'm too lazy to lug it down into the basement. But let's have a look at the CPU board and see what shape it is in functionally. I did a visual inspection of the board and nothing jumped out. It's the usual mess on Atari boards. It's got blue bodge wires all over the place. I mean, they kept upgrading this board, and I have never seen schematics that document what these are. Now, you can reverse engineer that, but my rule of thumb is when you see blue wires and they look like they were done at the factory, don't touch them. And if you have to touch them, such as replacing a chip that these attach to, clearly mark these wires so when you replace the chip you can reconnect them the way they were originally. But yeah, it came out of the machine. I dusted it off a little bit and I got it hooked up to a power supply now. And basically the way this board, the only input power-wise this board takes is 12 volts unregulated through this connector. And 12 volts unregulated on most machines I've checked is between 14 and 15 volts. Now I'm going to power it off a bench supply here, but this guy only goes up to 8 volts. And I mean, I have another one above it that goes to a higher voltage but doesn't have the current capability, because these boards, when working correctly, these particular ones will take in excess of 3 amps, somewhere between 2.8 and 3.2 amps. So I need to use this guy, which is good for 5 amps. But I've tested other boards with the same setup, and the 8 volts is more than sufficient for the 5 volt regulator housed in here to create 5 volts. I mean, this needs a minimum of 7.5 volts. But 8 volts is more than enough, as I've proven several times on the bench, to make it work, if it is functional, of course. So what you can see is I hooked up the handy-dandy bench display, test display I have here, which is partially out of the frame, there. I've hooked it up to the power supply. These two clips power the display, and the last thing we got to do is check what the power supply is set to. So the voltage is set to 8, current is set to 3.5 amps, because as I mentioned, it can take, this particular board can take up to 3.2 amps. Now why is that? This is like a first generation board. This is like revision 0 of the first, well actually it's revision 8, it says over here, but if you look at it, this has got 8 bipolar ROMs on it, from here to here, that contain all of the code. And this one has room for 2 more 24-pin chips. And in some of the later machines, they actually put 1K proms into these sockets and didn't use the bipolar ones. However, these bipolar ones are very power hungry and very slow, but the power hungry is what drives it up to above 3 amps to pull about 3 amps out of an 8-volt supply. I could sit here and remove these, put sockets in here and put 2716 EPROMs in here, but before doing that, let's power her up and see what happens. I mean, we may be at a point where one or more of these mask ROMs are bad, in which case we have to remove them and replace them anyway with more modern parts. Alright, so let's give it some power and see what happens. Turn on the power supply. Well, that's not good. It's doing the blinkety blink, which normally on these boards means that it's got a watchdog circuit in it, and if the CPU doesn't throw the watchdog a bone periodically, it resets the processor. Now we can see all 8s coming up. That doesn't really mean much. Basically everything's turned on. I mean, the DMA circuit is sending stuff out to the displays, but it still doesn't mean that the RAMs work. That it really doesn't mean a whole lot. What it means is that the reset is jumping up and down. And we need to find what's causing the processor not to run correctly. Could of course do the old song and dance, let's get started. Is the crystal good? Well, obviously the crystal's good. This kind of stuff can only happen if there's a clock running. But then, you know, check all the pins on the processor. However, one thing that's made me suspicious right off the bat is look at the current consumption. A board like this should be drawing around 3 amps. It's only drawing 1.3 amps right now. So what that means is, let's do the utterly obvious and check the 5-volt rail. Alright, I'm going to measure the voltage as far away from the regulator as possible, because that's kind of worst case. This is a TTL chip. So this is ground, and this is VCC. So we're getting a very unstable 2.5 to 3.2 volts out of this thing. So we got a problem with the regulator. And again, I have tested it. I've tested other machines, feeding them with 8 volts for the regulator input, and it doesn't bother them. So this guy must be bad. So let's pull a regulator and replace it. So here's what I found in my stash of parts. It's a replacement part, an LM323. Hello. However, if you look at it closely, it looks like somebody sanded down this part and reprinted it. These are hard to come by, so lots of fakes are floating around. And even worse than that is if you look at the pins, this is a pulled part. This was soldered in somewhere. So double jeopardy. Well, you know, why don't I just go out and spend $30 or $40 and buy a real one? Because I am cheap and adventurous, and you know, let's see. I paid $2 for this. I bought like a half dozen of them. So before putting them in, we're going to hook them up to the power supply and just see what the output voltage of it is. Of course, that's not conclusive because there's no load on it or anything, but what I found with these linear regulators is if you just hook them up dry and the output voltage looks good, they will usually perform fine in a circuit. So as I said, I just hooked it up to the power supply, no smoothing caps, no diode protection diodes, nothing. So it is getting 8 volts right now, and that is on the input. And this is the output pin. Well, it's giving us pretty good 5 volts, so it's not going to look the same once it's soldered into the board, but that's close enough for me to go ahead and replace the onboard regulator. Well, here you can see the regulators on the other end. It's screwed in, the case is screwed into these two bolts here, but you can see that these traces here are pretty large. You generally need a good bit of heat to get these joints to flow. So for that I use my deluxe Walmart iron that costs $10, comes in a kit, comes with solder, comes with a stand, if you can call it a stand. But for this kind of work, I mean, you shouldn't use a 30 watt on ICs. Well, this is an IC, but when you're having traces that are this large, you do need a little bit more power to get through to it. First, let's give it some fresh solder. That'll make it easier to get the whole thing to melt. And then couldn't find my solder sucker, but I finally found it. So let's see how much of the solder we can get out with this guy. Come on. Solder sucker is very sensitive. And it didn't do a very good job of getting any of this stuff out of here, so. Well, it gets the majority out, and then we're going to pull out some braid. This thing, it has a hair trigger. I don't know when it... Look at that. I just put my finger on the button and it triggers. Well, didn't get it all out, so let's get out the braid. There you go. I see it flowing. But these traces are just so thick. They act like a very good heat sink, which is the last thing you need when you're trying to desolder something. So it is being stubborn. So the third step is we're going to help it along a little bit by inserting a screwdriver underneath and then heating the joints and seeing if this is going to cooperate. Come on. Why does everything have to be so difficult to do? Okay, we'll do it this way. We'll grab the heat sink from underneath. And try it like that. Click. Click. See? Here's the old guy. And has a date code of 1977, 39th week of 1977. I'm sure there's quite a few guys in the audience that are younger than this regulator is. Anyway, let's put the new one in and see what happens. Another thing is they use the thermal pads in here. Well, it ran with thermal pads for 40-some years, so I mean, I should be putting heat transfer paste in here, but I'm going to leave this guy in there and just solder the new one in. Alright, the new regulator is in place. Let's see what that did. So we're going to turn on power, and here it goes. Well, it doesn't have the blinkies anymore, and it's exhibiting the expected behavior. That's what it does when you first turn it on. And if we look at it for a while, it will, I think it'll blank these displays, but the player indicators will keep going. And that looks good. Now on the bench there isn't, I mean, there's more stuff we can do. Check solenoid transistors for shorts and all of that, but I think what we're going to do is there's a way to simulate pressing the test button in the coin door, and if we get good displays once we put it into test mode. I mean, unfortunately this machine doesn't actually test the displays in that it lights up all of the segments and stuff like that, but if we get a nonsensical display, then we know things aren't fixed yet. But if things look okay in test mode, then we have a very high chance of this board being fully functional. So to put it in test mode on the bench, Atari was kind enough to give us a backup for the physical test button that's in the coin door on the game, but we can do that by flipping one of the dip switches. So what this does, it tells us what the replay levels are. So if you reach these scores, you get a free game. It tells us that it's in test 1. And what it's actually doing, it's lighting up all the lamps. And I could kind of test that with an LED, but I'm going to wait till the machine's in the workroom and then deal with that. It's telling us that there are the machine's set to 3 balls per game, and I can't recall what the 8 means, but we got a stable display, so that looks good. Now we can jump into the next test. Test number 2 still shows the scores, tell us it's in test number 2, and blanks out these displays. And what you got to do here is hit the flipper buttons, and it will activate the solenoids. But yeah, I don't have the flipper buttons, but still things look good. And then we do this again. It goes into test 3. Again, the same display, test 3. And what it'll do here, it'll show us switch closures on this display. So if you close switches, they will show up here. But it's stable. So let's see what happens if I hit the test button again. It resets. Okay. So it goes back to the beginning. For all intents and purposes, the board's working. But look for a future episode where I drag the machine in and install the board in the machine, and we can see the lights and the solenoids and the switches and all that wonderful stuff. One last thing I'm curious about is, so what is the 5 volts with the whole board attached and it running correctly? Remember, we were very close to 5 volts, just a little bit over. 5.007 when we bench tested the regulator. So now with everything powered up, everything running, we test from ground to power. That's pretty good. We're losing about, there's a 20 millivolt droop in the regulator. It's running at like 3.2 amps. So that's all good. Thanks for watching. Please like, subscribe, and comment. And we'll see you next time.